We'll be looking at double angles, right? This is a follow-up topic to our compound angles. So if you're doing grade 12, just note that when you're doing trigonometry, you need to be familiar with compound angle formulas as well as double angle formulas. Now, doing double angle formulas, we will firstly look at if the expression sine 2a is expanded using a double angle identity, then a new identity is formed. Now, what is that identity? Sine 2a, remember, becomes your equals to sine a plus a, and then that will be your sine 2a. If you expand it using the compound angle, it's sine a cos a plus cos a sine a, and in double angles it will be sine 2a is equals to 2 sine a cos a. So hopefully everybody gets that. I don't want to over explain. Any questions will be addressed on the comment section on the YouTube channel. Now we're looking at if the expression is cos 2a is expanded using a double angle identity, then a new identity will be formed. So now it's cos 2a, right? This one has 3 alternatives to tell you in advance. So let's start. Now with your cos 2a, you have your cos a plus a, and so cos 2a is equals to cos a by cos a plus sine a by sine a. You have your cos 2a equals to cos squared plus, rather minus sine squared a, right? So from this identity, cos squared plus sine squared a is equals to 1. Remember that identity, everybody knows it. We can therefore deduce that cos 2a, cos squared a rather, is equals to 1 minus sine squared a. So did you see that? Cos squared a is equals to 1 minus sine squared a. Remember it. Alternatively also, and sine squared a is equals to 1 minus cos squared a. So these are important, very important identities. You need to remember these because we will be doing a few examples and these will come up. Now let's look at it again. From the deduction, cos 2a is equals to cos squared a minus sine squared a, which is also cos 2a equals to 1 minus sine squared a minus sine squared a, right? So you have your cos 2a equals to y minus 2 sine squared a. Do you see how that came about? Hopefully you do see that, and then we'll carry on checking the other alternative for identities, right? So which is cos 2a is equals to cos squared a minus sine squared a. Now here your cos 2a is equals to cos squared a minus 1 minus cos squared a. So that in brackets, right? So that will give you your cos 2a equals to 2 cos squared a minus 1. So this is your other identity. So from all these identities, you have come up with 3 identities. The identities at the bottom, as you see them on the screen, cos 2a equals to 1 minus 2 sine squared a, as well as that cos 2a equals to 2 cos squared a minus 1. So these are very important, right? The other starts with the 1, the other ends with the 1. So you must see the distinction between the two. All of them are based on what? Your cos squared a minus sine squared a. All of them. So this is also another identity. Now let's look at quick examples here. Use the double angle formula of sine to expand the following. So we'll have our 3 questions, which is sine 4a, b will be your sine 50, c will be your sine a. So your solution for sine 4a will be sine 4a is equals to sine, and then you expand 2 times 2a, and then you will then get that is equals to 2 sine 2a times cos 2a. Remember, that's the expansion type. So for B, sine 50 is equal to sine 2 times 25, right? So remember that sine 50 is equal to 2 sine 25 by cos 25. Remember this. So this is based on which one? On the sine, right? To expand using the double angle. Now we'll be looking at a very important number C, which is sine A, right? For sine A, on the other hand, let's do this. Sine A, you get your sine A equals to sine. You have 2 brackets 2. You have your A over 2. And then you then cancel out the 2's. So you'll have your 2 sine A over 2 by cos A over 2. So remember, this is also another important double angle formulae. So for the rest, we will then use the double angle formulae of cosine to expand the following. So now we are expanding with cosine. So now we'll have your A as a question here, cos 6a. We have another question, cos 80. You need to expand these ones. And then you have your cos A. For your solution, A will be your cos 6a. To expand this, you have your cos 2 times 3a, right? So that can be written as cos 6a equals to cos squared minus, or rather cos squared 3a minus sine squared 3a. So that's your number 1 option. Number 2 is cos 6a equals to 2 cos squared 3a minus 1. Remember, now you are going to start with the 1 this time. Cos 6a, you'll have your 1 minus sine squared 3a, right? Remember, this is very important. For B, you'll have your cos 80 equals to cos 2 times 40 to expand, right? So when you have expanded, cos 80 is the same as cos squared 40 minus sine squared 40. So this is your alternative 1. For alternative 2, you have your 2 cos squared 40 minus 1, right? So now you know cos 80 again is equal to 1 minus 2 sine squared 40. So you have actually dealt with this very well. So now you'll do your C. Let's go to the C part of the question. Now for C is, which is cos A. Now you'll have your cos A. Remember, you always have 3 alternatives as your expanded forms, right? When you are doing cosine. So you'll have your cos A equals to cos 2 times A over 2. For that, you'll have your cos being cos squared being A over 2 minus sine squared A over 2 again, right? So you are getting the feel of it. Ensure that you practice your double angle formulas, guys. They always come up in your exams. And for your other alternative, now you have your cos A again, where you have your 2 cos squared, okay, you have your A over 2 minus 1. So remember, you have the 1 with the minus 1, and then you have the 1 that starts with the 1. So you have another cos A equals to 1 minus, this time is 2 sine squared A over 2, and then that's your last alternative. Once you've done this, you've done well. So please practice this, download this video, and share with your friends. Ensure you like the page, because we have a lot more coming in this series of compound interest.